Hello, how are you? I hope you're feeling good. Today I'll talk in my presentation about Listen to Unit 2. I hope you will take it. And if you have any questions, please don't be shy. I'll answer your questions privately on WhatsApp with all pleasure. This is Mrs. Rasad from Science Team at New Generation Language School. Today, inshallah, we're going to talk about the Listen to on Unit 2 Energy Transformations. First, to understand the concept of conservation of mechanical energy, carry out the two following activities. First, what when we flick the pendulum? First, pull a simple pendulum away from its original position to higher position, then leave it. About observations, the pole of the pendulum moves on both sides around its original position. So the speed of the vibrating pole decreases as it goes away from its original position and is maximum when it passes its original position during its movement. So the speed of vibrating pole again, number one, decreases as it goes away from its original position. Number two, it is maximum when it passes its original position. Perfect. And about the explanations. First, pulling the ball to higher position means doing work stored in the ball in the form of potential energy. Number two, when you leave the ball, the potential energy changes gradually into kinetic energy. Number three, when the ball passes its original position, its speed is maximum, so the kinetic is maximum and the potential energy is the minimum. So the mechanical energy in this state equals potential energy plus kinetic energy. Number four, when the pole reaches the maximum height, its speed is zero, so the kinetic energy is zero. So the potential energy is the maximum, and in this state, the mechanical energy equal the potential energy. And finally, and this is the very important point, the pendulum keeps the moving right and left around its original position, keeping its mechanical energy value constant. Why? Give reason. Due to the exchange between the potential and the kinetic energies. Perfect. And from the previous activity, we can summarize that the potential energy is maximum, so the kinetic energy equals zero. And when the potential energy is minimum, the kinetic energy is maximum. And when the potential energy is maximum, so the kinetic energy equals zero. So potential energy decreases when kinetic energy increases. Perfect. Give reason. First, the motion of the children's swing is like that of the pendulum. Number two, the mechanical energy is a constant value. Both of them has the same answer. And the answer is due to the exchange between the potential energy and the kinetic energy. Perfect. Don't forget that the potential energy and the kinetic energy changes, but the mechanical energy is the same. Perfect. Problem. A moving pendulum has a potential energy of 0.8 joule at maximum displacement B. If the mass of its pole is 0.16 kilogram and acceleration due to gravity is 10 meter per second square, calculate number one, the height of the pendulum's pole maximum displacement. Number B, the kinetic energy of the pole at such point B. About the solution, the object weight equal object's mass times acceleration due to gravity. So equal 0.16 times 10 equal 1.6 newtons. And the potential energy at the maximum displacement equal weight times height equal so the height equal 0.8 divided by 1.6. So the answer is 0.5 meter. Number B, the kinetic energy of pendulum at the maximum displacement B is 0 for sure. Perfect. And now we are going to talk about the transformation of energy. We have two types of transformations of energies. Number one, the transformation in simple cell. Number two, transformation of energy in the electric lamp. And finally, the transformation of energy inside the car. First, we'll start with transformation in the simple cell. In the simple cell, the chemical energy changes into electric energy. For sure. And what happens if a potato is used instead of the lemon? The needle of the compass will deflect due to the production of the electric current. Because a potato has a salt solution that has the same rule of acidic solution of lemon. Perfect. And what about the simple cell? The idea of the operation is it converts the chemical energy into electric energy. And about the construction, it consists of number one, a glass container containing a dilute sulfuric acid H2SO4. Number B, two metal plates are immersed or dipped in the diluted sulfuric acid. One of them is copper, positive pole. This is very important point. The copper is positive, and the other is zinc, and the zinc is negative pole. And what about the direction of the passage of the electric current in the wire? The electric current passes from the positive copper plate to the negative zinc plate. Amazing. So from positive to negative. Give reason. Immersing two copper plates in diluted sulfuric acid is not considered as a simple cell because the simple cell must has two different metal plates immersed in diluted sulfuric acid. So it must has two different metals plates, zinc and copper. Perfect. And now number two, the transformation in the electric lamps. First, in the electric lamps, the electric energy changes into light energy and heat energy. Super. Don't touch the electric lamps in your house on lightning. Why? Good reason, because they are very hot. So take care of touching the electric lamps in your home or in your house on lightning because they are very hot. And don't forget that the electric current flows through the closed electric circuit. Okay, remember in grade 6 I told you that the electric current flows through the closed, not the opened electric circuit. Okay, so in the electric lamp, the electric energy changes into light energy and heat energy. So don't touch the lamps in your house on lightning. We have here very important exercise. Dear student, how can you use the following materials to set a tool to let a deaf friend have attention, also to set another tool for the same purpose for a friend who can't see? The materials are an electric lamp, an electric bell, a battery, and a switch connecting wire finally. So about the answer, we have here two answers. The answer number one, a tool for a deaf person connect the electric circuit as known in the figure. Then close the switch. You observe that the electric lamp lights And about the tool for a blind person, connected the electric circuit as shown in the figure. Then close the switch. You observe that the ball rings. I think it's very easy. Transformation for energy number 3. We are going to talk about the transformation of energy inside the car. As you see in this picture, on operating a car engine, several transformations of energy take place in the car. So we will start with the chemical energy stored in the fuel inside the car engine. It changes by burning into thermal or heat energy, that it changes into mechanical energy or kinetic energy to move the car. So a part of it changes in so I said a part of that it changes in the dynamo into electric energy. So the electric energy changes into three states of energies or three energies. Number one, light energy in car lamps, and sound energy in the car radio cassette, and heat energy in electric heater of car air conditioner. Perfect. And now it's your turn. Complete the following. Planck, Planck, and Planck are examples of energy transformations. You have 10 seconds. Brilliant, Mustafa. Thank you so much. You're amazing. And now we are going to talk about the conservation law of mechanical energy. The energy is neither created nor destroyed, but it converted from one form to another. So energy is neither. Is neither created nor destroyed, but it's converted from one form to another. Thank you so much. And now we're going to talk about the effects of technological applications of man and environment. So first we're going to talk about the positive effects of technology. First, using energy resources for many purposes. Number two, changing energy from one form to another in some applications to be used in man's life. For example, energy produced, energy used, the process. First, potential, kinetic, on winning a spring toy. Kinetic to, from potential to kinetic on leaving the spring free. Kinetic to heat, rubbing your hands. Kinetic to heat and sound, hammering an iron piece. Kinetic to sound, metallic pole. Electric to heat, electric heater or fire. And now it's time for negative effects of technology. Environmental pollution as electromagnetic pollution, noise pollution, chemical pollution for air, water, and soil. There are some harms of technological applications when man uses them in wars and killing, massive destructions. And now some examples of negative effects of technological applications about the application, negative effect, and diseases. Car exhaust, air pollution, chest and eye diseases, military explosions, huge destruction, disease lead to death. Chemical pesticides, water, air, and soil pollution, cancer, nuclear weapons, huge destruction, diseases lead to death. Mobile webs, electromagnetic pollution, heart diseases. And now it's your turn, my dear friend. Complete the following. Number one, the energy never space nor space, but it's only converted from one type to another. Number two, the car engine converts the energy from Planck to Planck. The cell phone converts the energy from Planck to Planck, and you have 10 seconds and this and all these questions for Rahaf. Brilliant. Thank you so much, Rahaf. You're amazing. Dear friends, thank you so much for watching and see you later. Goodbye.